We now learn about the binomial expansion formula, which will allow us to write all the terms in any expansion looking like a plus b raised to some power n, where n is a natural number, so it could equal to 0, 1, 2, 3, 4, and so on. So for instance, by the time we're done with this section, we'll know how to write all the terms in the expansions of a plus b raised to the power of 3, or a plus b raised to the power of 7. The binomial expansion formula states that a plus b raised to the power of n equals to the sum from r equals to 0 up to n of the product of the binomial coefficient nr times a raised to the power of n minus r times b raised to the power of r. One thing worth pointing out immediately is that when we write all the terms in the expansion of a plus b raised to the power of n, it will always have n plus 1 terms. And this is important, and it's often asked in exam questions. So for instance, if we had to write all the terms in a plus b raised to the power of 2, then there would be 3 terms. Or if we had to write all the terms in the expansion of a plus b raised to the power of 7, then there would be 8 terms. And each of those terms is found using this expression we see just to the right of the summation symbol. That's the product of the binomial coefficient nr with a raised to the power of n minus r and b raised to the power of r. Here's how that expression actually works. Let's say we had to write all the terms in the expansion of a plus b raised to the power of 3. Then, according to the binomial expansion formula, this should equal to the sum from r equals to 0 up to 3 of the product of the binomial coefficient 3r times a to the power of 3 minus r times b to the power of r. Notice that all I've done to this expression is rewrite it replacing every n inside the expression by 3, and that's how that expression actually works. Furthermore, since we have a plus b raised to the power of 3, the expansion must have 3 plus 1, which is 4, and that's 4 terms in the expansion. Now, how do we actually find those 4 terms? What we do is we rewrite this expression that I'm underlining now by successively replacing all the r's we see inside it by all the values between r equals to 0 all the way up to r equals to 3. So in this case, that would be for r equals to 0, 1, 2, and 3, which we can see corresponds to 4 values, therefore 4 terms. And that would look like this. For r equals to 0, the expression becomes 3, 0 times a to the power of 3 minus 0 times b to the power of 0. We add on to that the case when r equals to 1. So that would be 3, 1 times a to the power of 3 minus 1 times b to the power of 1. We add on to that the case when r equals to 2. So that would be 3, 2 times a to the power of 3 minus 2 times b to the power of 2. And finally, we add on to that the case when r equals to 3, which would be 3, 3 times a to the power of 3 minus 3 times b to the power of 3. And simplifying those powers a bit would lead to the following. We can see here that we definitely have 4 terms, 1, 2, 3, and 4, and each of those terms was obtained using the expression we see to the right-hand side of the summation symbol. We'll see more of how to simplify this expression further with a couple of examples in our next tutorial. For now, though, the objective is to see how this formula actually works. Another thing actually worth pointing out inside this formula is this expression in parentheses here, this nr. This is known as the binomial coefficient, and its formula is the following. nr equals to factorial n over factorial of n minus r times factorial of r. For any of you who may be uncomfortable with factorials, here are a couple of examples. Let's say we had to calculate the factorial of 4. That would equal to 4 times 3 times 2 times 1, and that equals to 24. Another example could be calculating factorial of 3. That would equal to 3 times 2 times 1, which equals to 6. And two important results to always keep in mind are the following. The factorial of 1 equals to 1, and the factorial of 0 is also equal to 1. Keeping those in mind, let's see a quick example of how to calculate a binomial coefficient. Let's say we had to calculate the binomial coefficient 5, 3. Then using this formula, we can see that that should equal to factorial 5 over factorial 5 minus 3 times factorial 3. And that would equal to factorial 5 over factorial 2 times factorial 3. And that leads to 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. And this simplifies quite nicely. Indeed, we have 3 times 2 times 1 on both the numerator and the denominator, so those cancel out. We can also see that we have a 2 on the denominator, which will simplify with the 4 on the numerator, leaving us with just the 2 on the numerator. So finally, this will equal to 5 times 2 over 1, which equals to 10. And that's how we actually calculate binomial coefficients by hand. Okay, now that we've seen the binomial expansion formula as well as the binomial coefficient formula, and we've also seen how to actually use it and get started on writing all the terms of the expansion, let's quickly move on to the next tutorial in which we work through a couple of examples writing all of the terms in the expansions of a plus b raised to some power n.